I am Graeme Clarke. I feel very honoured to have been inducted into the Pause Awards Hall of Fame. For me, the Pause Awards signify being imaginative and curious on the one hand, and taking discoveries through to industrial and commercial development on the other hand. As a 5-year-old, I was imaginative and wanted to fix ears because my father was deaf. For that reason, I decided to be an ear doctor, but when I did become an ear doctor, I discovered no one could fix nerve deafness. So I decided to spend time sitting under a gum tree to think what might be possible. I came up with a plan. I would break speech down into different parcels of information and stimulate multiple pathways in the brain. Many scientists said I would be trying to do the impossible. I was called Clown Clarke in America, and some clinicians in Australia said it would be as effective as passing a light bulb up the backside and switching on the electricity. So, the University of Melbourne took a big risk in appointing me as the first professor of ENT surgery in Australasia and possibly the Southern Hemisphere. However, that position allowed me to do the research needed to see a multi-channel implant would be safe and effective. That included spending time to find answers to important questions. How could I pass a bundle of wires around the tiny spiral of the inner ear to stimulate the brain without it getting stuck? The answer came resting on the beach. I saw a shell like the inner ear and found that grass blades that were flexible at the tip and stiffer at the base would pass easily. That gave me the idea how we could develop an electrode, and it also passed easily around the spiral of the inner ear. I then had to find a suitable patient who was prepared to go into the unknown and take a risk. At the last minute, Rod Saunders came, and this is part of my interview.
What do you miss most?
What?
What do you miss most?
Well, I miss hearing the family, voices. I miss music. I even miss the sound of the dog barking.
Then, on the 1st of August, 1978, together with Brian Pyman, I operated on Rod at the Eye and Ear Hospital. The multi-channel electrode passed successfully around the inner ear, and the receiver stimulator fitted into his mastoid bone. But could we discover how to code speech sounds with electrical stimulation so they could be understood? After much work, I had a eureka moment when Rod heard different electrodes as vowels, as well as pitch-like sounds.
It sounded like, oh.
That gave us the clue how to develop a speech code, and in December 1978, Rod heard speech sounds with electrical stimulation of his brain without the need to lip read. I was so moved, I went into the next door lab and burst into tears of joy. I knew then that all the blood, sweat and tears of the last 11 years had been worthwhile. We had done what many said was impossible.
Came.
Came.
Cake.
Cake.
Can you hear me?
I can hear you.
Good.
But the job was not yet complete. I had to see our discovery get out to the world and help hundreds of thousands of deaf people. This meant industrial development. But Australia had only one medtech company, the pacemaker firm Telectronics. However, with funding from the Commonwealth and much support from the University of Melbourne, the company became Cochlea Limited and did a fantastic job. Paul Traynor, the owner, created a tiger team, and a clinical trial device was developed with lightning speed. I led its surgical trial in 1982, and it was exciting when my patient, Graeme Clarke, heard again. In 1985, the implant became the first multi-channel implant to be approved by the US Food and Drug Administration as safe and effective for deaf adults. Then, the next big question was, would it work for deaf children whose brains had never been exposed to sound? So, in 1985, I operated with Rob Webb on my first child, Scott Smith. When Scott commenced understanding speech, I operated on younger children, and Cochlea conducted a world trial. In 1990, it was the first implant of any sort to be approved for use in children. The Cochlea Limited implant has dominated the world market and been implanted in more than 700,000 deaf people in over 180 countries. Finally, I am delighted that the University of Melbourne, where much of the basic and clinical research was undertaken, has created an institute for biomedical engineering so that our work can continue. And they have kindly named the institute after me. The Graeme Clarke Biomedical Institute promotes and coordinates the extensive engineering activities across the University of Melbourne. This research includes better bionic ears, bionic vision, bionic spinal cords, the management of drug-resistant epilepsy, tissue repair, robotics, the treatment of heart disease, better vaccines, and much more. One special hope is that one day people with spinal cord injuries will be able to walk again. In conclusion, I would like to encourage young people who are curious and have an interest in science, technology, engineering, or maths to consider a career in research. It is very rewarding to make a difference to people's lives.